Today, we're going to start one of my favorite lessons of all. Trigonometry. Trig. You've heard of trig before, right? Everybody thinks trig is scary, but it's actually super simple once you know what trig functions are and how they work. They're real easy. It's sort of like a plug and play sort of thing. Now this is a mnemonic device. Mnemonic device is just a way of remembering something, right? The reason it was on the screen a while ago is because mnemonic starts with the letter M, which I just think is weird. But I told my second period class that they were like, what? So I had to show them that it really did start with M. And really was pronounced mnemonic. The M is totally silent. You don't pronounce it at all. Yeah, just there for looks, I guess. So, some old hippie caught another hippie tripping on acid. Now, this is one of numerous ways that you can remember the trig functions. Now, the trig functions, there are 6 trig functions, but in geometry, we focus on the main 3 trig functions. So, they are sine, S-I-N-E, cosine, C-O-S-I-N-E, excuse me, and tangent, T-A-N-G-E-N-T. Those are the 3 trig functions. And if you look on your calculator, you're going to see 3 buttons that are dedicated to these 3 trig buttons. They say S-I-N, that's the abbreviation for sine. Do not pronounce it sin, pronounce it sine. That drives me crazy. It takes no more energy to say the word sine than it does to say this word sin. So say it correctly. And then there is C-O-S, that stands for cosine. And then there is T-A-N, and that stands for tangent. Okay? Mm-hmm. 3 buttons on your calculator. If you look at your calculator, you'll see them. They're in a row. And I'm going to show you something for your own benefit. You got your phone handy? Get your phone out if you got it handy.
I don't have a phone.
Open your calculator. At all? That's a weird thing. So if you have your phone on you, you can take your phone out, open your calculator, and then turn it sideways. Turn your phone sideways. When you turn your phone sideways, you will see that you now have sine, cosine, and tangent on your phone. So if you are not here, if you're not at school, you don't have a calculator, you could still do sine, cosine, and tangent. You have it on your phone calculator. Now, let's say you don't have your phone or your calculator on your phone is broke. If you open the calculator on your Chromebook, so your calculator app will probably look something like this. And see where it says standard right here? If you click these little 3 buttons right here and you change this to scientific, see where it says trigonometry? That gives you sine, cosine, and tangent. If you make it bigger, you make it full screen, then, oh, they still don't show up. They used to. Used to, they would be over here. But you get the trig functions right there. So even if you don't have your phone, if you have your Chromebook, you still have access to sine, cosine, and tangent. Okay? You don't have a Chromebook and you don't have a phone, I guess you're SOL. Okay. Now, what do these things mean? What is sine? What is cosine? What is tangent? So, sine, cosine, and tangent are just ratios of side lengths on a triangle. So, this O stands for opposite. And we're going to talk about opposite what does that mean in just a minute, okay? I'm just giving you the information right now. H stands for a word you are familiar with. We use the word hypothesis a whole lot in geometry, do we? No, but which one do we use a whole lot? Hypotenuse. A stands for adjacent. And H stands for hypotenuse. And then guess what this O and this A stand for down here? They still stand for opposite and adjacent. We didn't change it all of a sudden. So now what does that mean, opposite and adjacent? Well, that's talking about sides of a triangle, right? You know that the hypotenuse is always what side of the triangle? Maybe I should have started with this. This is right triangle math, okay? So we're totally talking about right triangle math. Where is the hypotenuse on a right triangle? Always. It is always the side across from the right triangle. The right angle. So here's the right angle. That's the hypotenuse. Okay? Always. Always, 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 always. That's how you find the hypotenuse. Go to the right. Huh? Yeah, it's pointing to it. That's right. Now, when we're talking about the opposite side and the adjacent side, those two sides depend on which angle we're talking about. So if we're talking about this angle right here, if this is our angle, and you'll see this little symbol right here, that symbol is a Greek letter called theta. And that we use that when we're indicating a specific angle. Okay, so if we're talking about that angle right there, if we go across the triangle to this other side, guess what that one is? What do y'all think that is? Between the words opposite and adjacent, which one? Opposite, because it's on the opposite side of the triangle. So that's the opposite side. And then this side, see how this side is touching the triangle? That one is the adjacent side. Okay? But if we take the exact same triangle, right? Exact same triangle, this is still going to be our hypotenuse. But if we talk about this angle now instead, now our opposite side is over here. And this side is our adjacent side. So see how opposite and adjacent depend on which angle you're talking about. Y'all see that? Okay, everybody understand what I'm saying? Okay, so let's put this into a little bit of practice. Okay? Now, all we're doing right now, is writing down the ratios of the sides. Okay, that's all we're doing. And that's what the trig function is. It's the ratio of those sides. Okay, so if I ask you to find the sine of angle R, and we come over here to this triangle and see they gave us these measurements for each side. So little side R is 16. Little side S is 30. Little side T is 34. Everybody see where I'm getting that from? It's like they gave it to us in the problem, right? And I ask you to find the sine of angle R. Now let's think through our little way of remembering it. Some old hippie caught another hippie tripping on acid, right? Some old hippie. Now what does O stand for? Opposite. So what side is opposite of angle R in this diagram? The 16. So the 16 is going to go on top. And then what goes on bottom? $34, right? It's the hypotenuse, so it's 34. Now, of course, we would excuse me. We would normally simplify this. But just for today, just to make things go a little faster, we're not going to worry with simplifying it. But we are going to go ahead and divide it out and write it to the nearest hundredth, okay? So what is the nearest hundredth if you do 16 divided by 34? .47. So 0.47 or 16 over 34 is our sine of angle R. That's the sine of it, okay? Now let's do cosine of angle R. So cosine of angle R, some old hippie caught another hippie tripping on acid, right? Some old hippie caught another hippie, right? Caught another hippie. So what does A stand for? Adjacent. What is the adjacent side to angle R? 30. And what's the hypotenuse? So it's 30 over 34, right? And of course we could simplify that, but we're just going to go ahead and divide it out today. So what's 30 divided by 34? 0.80? 0.88, okay. So that's the ratio for cosine of R. All right. So far, so good? Okay. What about tangent of angle R? What is the tangent? So some old hippie caught another hippie tripping on acid. Tripping on acid, right? So we look at angle R again, and we say, what's the opposite side for angle R? So what is the opposite side for angle R in this diagram? 16. And what is the adjacent side for angle R? So 16 over 30 is our ratio. To the nearest hundredth, what is it? 0.53 repeating. So we're just going to put 0.53 because we're rounding to the nearest hundredth. So we don't need to put the little line over it because we're rounding. Okay. So that's for the sine, cosine, and tangent of R. But what happens if we switch angles? And now we're talking about the sine of S, the cosine of S, and the tangent of S, right? So what's the sine of S? Some old hippie. Old hippie. So opposite over hypotenuse. What's the opposite side from angle S? Think again. Opposite side from angle S. Well, the big S is the angle measurement, and the small s is the side. So we're talking about angle S, so that's the big S. So here is here's the angle. What is opposite of that angle? 30, right? So this is 30. What's the hypotenuse of this triangle? 34. It didn't change, did it? That hypotenuse stayed the same because that right angle didn't change. That right angle is still in the same location it was, right? Does that sound familiar, 30 over 34? Didn't we do that just a minute ago? Which one was 30 over 34? Cosine. So the cosine of one angle and the sine of the other angle are the same thing, right? Well, let's think about that. Remember, cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. And if we're talking about angle R, the opposite side is 16. But if we're talking about angle S, the adjacent side is 16. So that side 16 is opposite for one, but adjacent for the other. Do you see why they're the same? Because you're still on with the same side. Okay? What about cosine? So some old hippie caught another hippie. Right? So what does A stand for? Adjacent. So what's adjacent for angle S? What side is adjacent? 16. And what side is the hypotenuse? 34. And remember, we did that one earlier. Which one was that the first time we did? It was sine, right? Sine of angle R. So sine of angle R and cosine of angle S are the same thing. So sine of angle R, we already did that math. We don't have to redo it. 0.47, right? Y'all with me so far? I can't tell if y'all are just quiet today or if you're just not with me. Just not energetic? Okay. What about tangent? Some old hippie caught another hippie. What is it? Does anybody know? Tripping on acid. So, what does O stand for? Opposite. So, what's the opposite side for angle S? 30. What is the adjacent side for angle S? 16. So, 30 over 16. Now, notice this is not the same as this tangent, but they're very similar. What's different about them? It's a reciprocal. Because the opposite and the adjacent changes based on which angle you're talking about, right? So where the adjacent for what's the adjacent for one becomes the opposite for the other one and vice versa, right? So what is 30 over 16? 1.88? Okay. All right, does everybody see how we did that? Okay, so I'm going to give you a chance to do number 2 and let's see if you can get them right, okay? But before we do them, let's think of that phrase and everybody's going to write it up here. So instead of writing the words out, we're just use the letters, okay? So let's do it together. So some old hippie caught another hippie tripping on acid. Now I do want to tell you there's another method that you could use that a lot of people really like. I personally prefer this method. This is easier for me to remember. But another method that people use is SOHCAHTOA. Now, for me, y'all know I can't spell. So the only reason I spelled this correctly is because I know what it is, right? But if I was trying to remember how to spell SOHCAHTOA, I would not get it right, I promise you. It would be spelled completely wrong. But if you are good at remembering spelling things, SOHCAHTOA may work better for you than this one, okay? So, same thing, right? Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay? So you guys, you're going to do number 2. Let's look at what's happening here. So on number 2, they gave us new numbers. They said little r, so the side is 10. Little s, that side is 24. Little t, that side is 26. Right? So you've got new numbers to use, but you're still going to be finding the sine of r, the cosine of r, the tangent of r. And then you're going to find the sine of s, the cosine of s, and the tangent of s. So you're still finding the same stuff. You're just doing it with different numbers this time. Okay? So I'm going to let you work, and I'm going to work on mine, and then we'll see how you did, okay? Have y'all done this problem? No? Because I see all white on your paper. You only going to get out of it what you put into it. Only going to get out what you put in. That's everything in this world. You only get out of it what you put into it. What's it? Sine. Mm-hmm. It's S-I-N-E. Sine. S-I-N is just the abbreviation. Bless you. Alrighty. Did you get the same thing I got? Okay, so you're getting the concept of how to plug it in, right? Okay. I know right now you're thinking, what's the point behind this? This is going to take us a few days to go through this lesson, okay? And once we're finished, you'll be like, oh, okay, I get the point. But right now we just got to learn the content. We just have to learn the information, all right? Now, what we are about to do is you're about to see that this works no matter what. So I want you to take your calculator. You got your calculator? And I want you to hit this button that says mode right here. Y'all see mode? It's right beside the blue button. On the third line, do you see where it says radian and it says degree? When we're doing trig functions, our calculator has to be in degree mode because we're measuring the angles in degrees. Radian is a different way of measuring angles, but in this class, we don't use radians. You'll use radians when you get to Algebra 2, but for right now, we're just focusing on using degree measurements, okay? If you do trig functions on your calculator, like if you punch in sine of some number to get the trig function of that, the sine of an angle, and your calculator's in radians, it's going to give you the wrong answer. It has to be in degrees. So to put it in degrees, arrow down to it, arrow over to degree, and then hit enter so that's black. Before y'all leave the room today, I'm going to have y'all switch them back to radian so that 6th hour has to change them too. Okay? Everybody with me? Okay, so is yours in degrees? Now, how do we get out of this? Well, there's two ways. You can hit clear, or you can hit second mode, and that goes back to quit. Second mode works everywhere on the calculator. Clear only works in some places. Okay? So you need to know that second mode, which is quit, get you out of, like if you're in the graph and you don't want to look at a graph anymore, or you're in the y equals screen, or whatever you're at, if you hit second mode, quit, that takes you back to your home screen. Okay? Okay, now, we're going to talk about this little triangle right here. Huh? It's a little bitty triangle. I almost couldn't draw it. It was so little. Now, that is what kind of triangle? It's right. It's a 30, 60, 90. How do we know it's a 30, 60, 90?
60 and a 90.
That's a 60 and a 90. So what does that one have to be up there? It has to be 30, right? So that has to be 30. Now, remember we learned last week that the short side of a 30, 60, 90 is like 1, right? And the long side, which is across from the right angle, is like 2. It's 2 times that amount, whatever that is. And then the medium side, excuse me, is whatever the short side is times the square root of 3, right? So this would be 1 times the square root of 3, which is just the square root of 3. So it's 1, 2, square root of 3. Y'all remember that from last week? Now, if we were to find the sine, of that 30-degree angle, we're going to call it A. So if we were to find the sine of A, right? Sine is some old hippie. What is that? SOH, but yeah. What's the O stand for? Opposite. What side is opposite of angle A? No. I mean like a number. 1, right? What side length is a hypotenuse? The 2. So we just learned that the sine of A is 1 over 2. The sine of that 30-degree angle is 1 over 2, which is what? What is 1 over 2? 1/2, right? That's 1/2 or 0.5, right? Now, I want you to look at this guy. Tell me what you know about him. It's also a 30, 60, 90, right? He's also a 30, 60, 90, which means this is my short side. Which one am I on? I'm on the wrong triangle. This is my short side. So let's say it's 3. If this short side is 3, how long is the long side? 6, because it's 2 times that, right? How long is this side over here? No, remember 1, 2, square root of 3, right? So this is 1, this is 2, this is... We're just going to leave it as 3 square roots of 3 for right now. We'll just leave it like that because it'll be easier to use. Okay, so 3 square roots of 3. Because it's the short side times the square root of 3, right? We learned that, was it last week or this week? Maybe in this week. So if we want to find the sine, we're going to call this DEF, right? If we want to find the sine of E, which is the 30-degree angle, right? If we want to find the sine of E, sine is some old hippie. So O, that's opposite side. What's the opposite side of E? And what is the hypotenuse? What does 3 over 6 simplify to? 1/2. Y'all seeing what I'm seeing? If we look at this one, we've got another 30, 60, 90. Let's say this side is 5. Yes, sir. Yeah. If this side is 5, what is this side? 10. What is this side? 5 square roots of 3. Right? So if I do, let's call this LMN. Okay? So if I want to find the sine of M, which is my 30-degree angle, it's going to be 5 over 10, which simplifies to 1/2. Do you see how we're still getting the same numbers? What if we do this big guy? And let's say I tell you that this side right here is 12. What is this side over here? What is this side over here? So if I do the sine of y, which is my 30-degree angle, right? What's that going to be? 12 over 24, which is 1/2 or 0.5, right? Do y'all see how we're still getting the same thing every time? Now, let's say, if we did the cosine, we would still get the same thing. If we did the tangent, we would still get the same thing, right? Now, I want you to take your calculator that we just put in degree mode, and I want you to hit the button that says sine. This one right here. And then I want you to put 30. We're going to find the sine of 30 degrees. Now, if we were doing something to this, we would need to close that parenthesis. But we're not doing anything to it, right? So there's no point in closing the parenthesis because we're not doing anything. We're just going to find the sine of 30 degrees, and we hit enter. 1/2. Exactly what we've been finding, right? The sine of 30 degrees is 1/2 no matter what size the triangle is. Does yours not say that? Hit mode. What'd you get, David? Like negative something? Which we know can't be right. Because side lengths of a triangle can't be negative values, right? And the only way you can get a negative if one of the things you've got is a negative. And sine is the ratio of the two sides, and those sides can't be negatives. So we know that negatives can't work, right? Did you get it fixed? Did you put sine of 30 in? And you got 0.5. So if you get... Now, sometimes you won't know that it's according to what angle measurement you have. You may not get a negative, so you won't know that you have it in wrong. You always got to check it, okay? Always got to check it. Because the default mode for your calculator is radians, and I don't know why. Because we're much more likely to use degrees in a calculator than we are to use radians. But for some reason, the default mode is radians. Okay. Everybody with me so far? So far, so good. Do you see how the ratio is the same no matter what size the triangle is? Now, we just did it with a 30-degree angle, but we could do it with any triangle. If we did, let's say we did a, yeah. Okay, if we did a 3, 4, 5 triangle, right? That was one of our Pythagorean triples we learned about. A 3, 4, 5, right? And I asked you to find the sine of angle C. The sine of angle C, right? So angle C is here. Sine is opposite over hypotenuse. So what would be the opposite side from angle C? Where are they going? So where are they going? Oh, real quickly. Better wait till Anthony gets back in here so he hears this. And Jonathan. Okay, so the sine of angle C. What's the opposite side from angle C? A is not a side. A is an angle. What's the opposite side from angle C? 3, right? What is the hypotenuse? You seriously did not just ask me what the hypotenuse was. Hypotenuse. It's 5. The hypotenuse is always across from the right angle. Beyond the fact that I just said this like 4 times today already, we have covered this all freaking year long. Yes, like an arrow pointing to it. That's right. The right angle points to the hypotenuse. Okay, so the sine of that is 3 over 5, right? So if I make a doubled up version of this triangle, and this is 6, and this is 8, and this is 10, and this is X, this is Y, this is Z. And I ask you to find the sine of Z, because Z is in the same place that C is, right? What is the sine of Z? 6 over 10. And that simplifies to what? What goes into 6 and goes into 10? 2. How many times into 6? How many times into 10? Do y'all see? See how it's the same thing? Y'all follow what I'm saying? Okay, on Tuesday of next week, and I'll try to remember to remind you on Monday, but I'm telling you today. On Tuesday, I will be giving the ACT test. You are going to go to the Coliseum. Okay? For my class. Not go to the Coliseum and stay all day long, but you're going to go to the Coliseum during my class period. So we don't take that? Not the ACT. That's just juniors. We'll take the ACT Aspire like next month.
Didn't we already take the ACT?
I mean, I don't know what you've taken. I don't know if you've taken the ACT or not. We have not taken the ACT Aspire, which is our test. 10th graders take the ACT Aspire. They're completely different.
I had the same questions.
Yeah, they're completely different.
I took it in December. No, I don't remember when.
Are you thinking Star Math?
No, I took it on a Saturday.
Oh, ACT. Yeah, that's... The juniors have to take the ACT at school one day. But the ACT Aspire is different. It's not the same.
Yeah, I took the ACT.